Hello. Fine. In last class we have covered about the IPv4, but there is one more concept. This concept is related to subnetting, because in IPv4, how many IP addresses are available? Good. 3.2 billion. And now you all can understand that every device requires a unique IP address. Then there must be few concepts by which we can use limited IPv4 all over the world, not all over the world, in the universe, because network is also available outside of the right. Yes, sir. To use these limited IP addresses properly, different techniques have been introduced and used successfully. One is NATing, Network Address Translation. I think you know about it, or you may not. But after routing process, you will cover it. Fine. Second is proxy. Have you heard about it? Proxy. Proxy server, proxy setting. You can see it in your phone also, at your PC also. Proxy. Fine. Then one more concept is subnetting. Subnetting, VLSM, and supernetting. Your data communication paper is going on? No. In next semester. Fine. In next semester, you will have to study about it. What is IP address? What are their classes? What is difference between IPv4 and IPv6? And what is NAT? What is subnetting? What is supernetting? Fine. VLSM is beyond your scope, the data communication scope. Fine. But these things are very important. For example, you have good idea about IPv4. I know IPv4. I can put into my PC. I can put it in my phone, laptop. I can use it. But when you will see these IP addresses at corporate machine or in bank or anywhere in a large network, then you will have a very different picture. What are these? I have not studied about it. IP address is this, for example, 10.0.0.1. Fine. And the subnet mask will be 255.0.0.0. This is the default subnet mask. This is the default subnet mask. Fine. But if I'm saying that you can use subnet mask like this, it will be very difficult for all of you to say this is the wrong, this is the right IP address and subnet mask. No, sir, I have seen a wrong IP address at a PC in a bank. Why? Because subnet mask was wrong. In class A IP address, subnet mask was given of class C. But actually, there is a lack of knowledge. Actually, we don't know how to use subnet mask. Fine. This confusion will be cleared by me after giving you concept about subnetting, VLSM and super. Fine. I have already given, but this is the revision class. So we have to cover it fastly. Fine. Now, wait. Submitting VLSM superlative. Fine. Suppose same diagram, I am going to use the same diagram. There is a company or network in which I have to define 4 different departments. These departments should be in different networks. Okay. For example, this one is account, sales, production, marketing. These are the 4 departments in a company. In account department, we have to put 5 PCs. In sales, 10. In production, 20. In marketing, 50. 50, or you can say 30. But as per the director concept, as per the company owner concept, these departments should be in different networks. Why, sir? For security reasons. Because when when 4 roads are coming, there must be a crossing. You can say Golumbar, Gol Chakkar. Why this crossing is required? To control the traffic, vehicle traffic. Fine. The same thing happens with these 4 networks also. Whenever it is required that, okay, salesperson should not contact you production department, because in production it is very clear that the object cost is around 5 rupees and salesperson has to sell it in 50 rupees. Fine. Coca-Cola, its cost is hardly 80 paise. 80 paise. Fine. And we are buying it in 12 or 15 a single bottle. Fine. But it's okay, it doesn't matter for us. Fine. We have to simply stop communication between these 4 networks. Now, to define these departments into different networks, we should use different IP range as per the requirement in each department. Which class is suitable? Class A, Class B, or Class C? Class C, because Class C gives us very less host in each network. Maximum host in Class C? Maximum host 8 bits. Okay. How many hosts can be connected to a Class C actually? 254. Somebody has given answer. 254. Correct. Total 256. But we reduced to minus 2 just because of network IP and broadcast IP. Okay. Now, Class C. Okay, fine. For account department, I have to give IP address 192.168.0. Fine. One network sells 192.168.1. Production 192.168.1. Sorry, not 1, 2. Dash. Marketing. Say. 3 dot dash. Fine. By using these 4 different range of class C IP address, we are actually using 1024 IP addresses. Is it correct? Because in each range there are total 256 IP addresses.
Yes, sir.
256 into 4, 1024. We have to connect only 5 plus 10, 15 plus 20, 35, 35 plus 30, 65. We require only 65 IP addresses. Actual requirement is 65. But how many IP addresses we are using? We are using 1024. Means there is a huge waste of IPv4 addresses.
Yes.
Where is the mask? Mask. Now we are mask. You can come here also. Okay. Now. Now, I am going to use concept of subnetting to reduce the wastage of IPv4 addresses. How? As you have seen, as you all have seen that in class A, subnet mask is to default subnet mask is to in class A, default subnet mask is 255.0.0.0. Means in class A we can connect more hosts. In class B 255.255.0.0 less hosts. In class C 255.255.0 very less hosts. Means as we increase the value of subnet mask, as we decrease the connectivity of host or IP address for host, means to reduce this wastage, we should make some changes with the subnet mask. Fine. Subnetting. Subnetting is a process. You can write also. Subnetting is a process subnetting is a process by which we can divide a default series of IP address into small and equal subnets. Small and equal subnets. Fine. No. Fine. How can we divide a default series of IP address into small and equal subnets? By changing the value of subnet mask. By changing the value of, right? By changing the value of, yes. By changing the value of default subnet mask. Default subnet mask. Right? Default subnet mask. Now, I am going to take only one series. Only one series. One 192.168.0.dash. Default series, default subnet mask 255.255.255.0. Fine? Yes. Now, look at this diagram. Maximum requirement 30. Maximum requirement 30. 30. Now, if we will use the maximum requirement, and as per this requirement, we will divide this IP series. Then all departments in which 5, 10 or 20 requirements can be fulfilled, right? But whenever we calculate about the maximum requirement, we should always use +2, because in each subnet there must be a network IP and broadcast IP. Network IP and broadcast IP. Fine? Means total maximum requirement is 30. Okay? As per the definition, we can divide a default series into small and equal subnets by changing the value of default subnet mask. So how can we change the value of subnet mask? The value, the subnet mask, actual subnet mask is 255.255.255.0. If we will convert it into binary, then we will have 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. Right? Now, look at this table. 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096, 8192, and so on. This is a table. You have to keep it in your mind. But, and you must learn it by heart. Maximum requirement is 32. Maybe it will be 50, 70, 10, anything. As per this requirement, which value can be used? 32. Exactly match? Yes, sir. Suppose that there is a maximum requirement of 20. 18 plus 2, 20. Then 32. 25, 32. But 40, Then 14, 16, correct? 100, 198, 490, perfect. This value is known as block size. 32, fine? Yes, sir. Now, just count number of values just before the 32. 1, 2, 3, 4, 5. These 5 points represent the host bit. These 5 points represent the host bit. Fine? So now, host bits is equal to 5. How many bits are there in IPv4? 32. Out of 32, 5 are used for host. Then network bits will be 27. Perfect. Network bits 27. 27 plus 5, 32. Correct? Now, then, how many network bits are there? 24. 8 3 are 24. Yes, sir. Now, next value will be 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. And 1 2 3. Now it is 27. 1 2 3 4 5. Are you all able to understand? Yes, sir. Good. Now convert this value into decimal. It will be again 255, 255, 255 and 224. Is it clear to everyone? 224? Yes, sir. Good. No. If anybody has any confusion that how my classmates have calculated 224, please raise your hand. Please raise your hand if anybody has any confusion. No confusion? Good. Now it is 224. This subnet mask will be used in each subnet, means for these departments. This subnet, in this subnet, in this subnet, and in this subnet. Correct? But how can we calculate different subnets? And how many subnets can be formed? There is also a question. Sir, how many subnets can be formed in class C if the subnet size will be 32? Number of subnets. Number of subnets. How can you calculate it? Just use 2 to the power 2 raised to the power n. And n is equal to number of extra bits. Extra bits. Extra host bits. Sorry, network bits. Okay, fine. I'm going to do it. Number of extra network bits. Extra network bits 3, because default 24 and after changing the value we have 27, means extra network bit is equal to 3. Fine. Eight means total subnets will be 8. Fine. And now you can simply add these things. Like 32 plus 32, 64 plus 32, 96 plus 32, 128 plus 32. 160 plus 32. 192 plus 32. 224 plus 32. 256. Fine. Now, how can we calculate the range of each subnet? From where first subnet will start and from at which value the first subnet will end. To calculate, just remove this value. Use this concept 0 plus 32. 32 plus 32 plus 32 96 plus 32 128. Now, first range of IP address for any subnets for any department 0 to 31. Perfect. 32 to 63. 64 to 96 to 125. Now we have to write only the network by using these 4 values. Now the first network will be 1. Suppose I am going to account 192, 168, 0.0, 192.168.0.1 and 192.168.0.13. 192.168.0.13. This first IP will be network IP. This last IP will be broadcast IP, and this from 1 to 30 broadcast IP. Fine. In the same way, we can use for second department cells. 192.168.0.32, 192.168.0.33, 192.168.0.62, and 192.168.0.63. Network IP, broadcast IP, valid host IP. Any doubt? Fine. Yes, yes. Yes, thank you. Now you can understand what is the value of your face. Fine. Now I am going to change the requirements of different departments. Now you have to answer, and the answer will be given by only that student to whom I will point. Right? Now the requirement is like 5, 7, 12, 5. Okay? Fine. Now. Yes. Maximum requirement. Maximum silence. Maximum silence, please. Maximum requirement. 12. Maximum requirement 12. Sit down. Please. 12. Fine, sit down. Yes. 14. Maximum requirement is actually 14. Fine. Maximum requirement 14. Yes. Use. Block size 16. Perfect. Block size 16. Yes. Use. Host fix 4. Sit down. Network bits 12. Sit down. 28. Fine. Network bits 28. Okay. Yes. Subject mask. Subject mask. What will be the subject mask? Okay, please. Subject mask, sir, please. No, just give me this value as I have calculated in the subject mask. We can write like this: 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4. 1, 2, 3, 4. Sorry. 28 times 1. No, just calculate it into decimal. What will be the answer? 240. Yes, 240. Fine? Okay. Subject mass will be 255. 255.240. It's okay. 240. And now, network range for different departments. The first range will be 0 to 15. Perfect. Second range 16 to 31. And third range 32 to 47. Fourth range 48 to 63. Correct? I think you all have idea what is that. Now see the result. In defining these four departments into different networks, initially we have used 1024 IP addresses. Now we are using only 32 plus 32, 64 plus 32, 92 plus 32, 128. By using only 128 IP addresses, we have defined four different networks. Means we have reduced the wastage of IPv4 addresses. Yes, sir. Is it correct? Is it correct? Yes, sir. Fine. Now, thanks for today. Any question? Any doubt? The same concept can be used for class B and class A also. Okay. So I am giving you a homework. HW. Now you can recall your school session. Yes. Homework, classwork, etc., etc. Right? Four departments. Requirement 50, 20, 100, not 100, 50, 20, 10 and 5. But you have to calculate it in class A. Class A. You all will use this IP address 10.0.0.0. Fine? And its default subnet mask is 255.0.0.0. Okay?